Exercise 4A, question number 1. It's about the experiment of a treatment and the loss in weight. We can see the scattered diagram on the plotted. And the question number A, describe the type of correlation shown by the scatter diagram. So now, when you look at these points, so I think that you can represent this data by a line. It is fair to represent this data by a line. Yes, if it is fair, then uh, there is a correlation. And then, so what is the gradient of this line? There is a positive gradient or negative gradient. The gradient is positive. So hence it has a linearity, which is the relationship is linearity, which is it has a um, correlation, and the gradient of the line is positive. It means it has a positive correlation. Positive. And we interpret the correlation in context. So what you can see that when the treatment is, what is the characteristics of positive correlation? The characteristics of what is positive correlation is we discuss when x variable increasing, y variable also increasing. The explanatory is increasing, the response also increasing. In that, so we can see that when the treatment time is increasing, the loss in weight also increasing. So we can tell that the longer the treatment, the greater the loss of weight. Question number 2. Uh, the question is about average temperature. Average temperature and average rainfall. Um, now, uh, this question number 8, describe the correlation between average temperature and the average rainfall. When you look at this question, the scatter diagram, do you think that you can represent these points by a line instead of all scatter diagram? Can you do a line to represent? No, it's not possible. So hence there is no linear relationship. It means there is no correlation. There is no correlation. Part B. Comment on the claim that the hotter cities have the less rainfall. So when you look at hotter cities, okay, let's say 30, 35, or rainfall is 0, we can see. But how about hotter cities have less rainfall? It means so the statement is something like this: hotter cities have less rainfall. So can you represent this scatter diagram by like with the line? It's not possible. So the graph does not support the statement. Also, I can see one example around 25, 27. The 27 rainfall is 0, and the 28 one is around 180. So this is also contradicting data. Overall, uh, the scatter diagram does not support the given statement. So you can write the statement in here be statement. Water cities have water cities have less rainfall. Question number 3. It is about an experiment about a bag of sweet, and 8 students were asked to guess the weight, and then without touching, and then touch and tell the weight. So this is weight not touching, and then after touching. For example, this cost will tell that this value is before touching for the same sweet bag, and this is for after touching for the same bag. So, and you may get this kind of a scatter graph, but you have to draw in a graph paper properly, not like me. And then question number A. So we want to discuss the linearity. The scatter describe the and interpret the correlation. Yeah, done. B. So we have to interpret the correlation. Can I represent this diagram, the scatter diagram, the points by a line? Yes, if I can represent, then there is a linear relationship. So this is the best one, not this one. There is a linear relationship. If there is a linear relationship, mean it can represented by a line, then the gradient line is positive. It means it has a positive correlation. And we want to interpret the data. When you look at, we can see that if a student gets a greater weight before touching, then what will happen after touching? So more likely to get a greater weight after touching as well, because this is the characteristics of positive. When one is increasing, the explanatory is increasing, explanatory is increasing, response also increasing. So we want to bring this idea in terms of the wordings. So we can tell that if first before touching, then greater more likely to predict greater we predicted greater weight after touching. If a student gets a greater weight before touching, then more likely to be predicted a greater way after touching. Question number 4. When you draw, you have to draw properly with a graph. This is a rough sketch, and you may get this kind of graph. So this one, do you think that you can represent by a line? Um, uh, yeah, we can represent by a line, but it has a correlation, it has a linearity, but that linearity is not strong. It is a weak linearity. Weak, in other way, weak correlation. Weak mean uh, increase in or decrease in of a explanatory variable. The response variable react very slowly. When one variable increases or decreases, the other variable responds very slowly. That's why um, it is that's the meaning of weak. So we can tell that weak negative correlation. And part C, give one reason why the donor's conclusion may not be valid. Because this is about the causality. I mean, if there is a real relationship between these two variables, the house price and the time, this is where our common sense work. So we have to use our common sense. The internet speed and the house values. Do you think that when the house values is increasing or decreasing, the internet speed is changing? The internet speed is depend on the value of the houses. I know internet speed depend on the capacity or the if it is a line connection, the type of wires used for that connection. Fiber optics ones is faster. Likewise, I know that internet speed depend on those kind of stuff. But how about the house values? So this is uh, not straight. There may be another variable relating to this. So, for example, assume that in urban areas, uh, the internet connection is very strong, and when it is going to outskirts, the internet connection is very low, because that's how the providers set um their waves. If this is urban area and this is urban area and others area, this is urban areas or other areas, rural areas, and in these areas internet connection is very high. At the same time, the house price also in this area very high. When you look at London, Manchester, or the Birmingham, likewise when around the town center areas, it is very house prices are very high. Because of that, we can't predict that. We can predict that, okay, when the houses prices are increasing, the speed is it has a fast speed basically. So when the house price is high, within 5 minutes download speed very high. So within short time, anything can be downloaded. So it is not true. It is not true for the reality, but for the graph it's fine. So this is the causality. So we'll answer there. maybe intermediate variable or third variable. That influences both house and house value and the internet speed. There may be intermediate variable or third variable that influences both house values and the internet speed, such as distance. So the distance is the intermediate or the third variable. Question number 5 is about rain and sunshine, and there are some values. The table shows the daily total rainfall and the total hours of sunshine. They will give. So first question is show that uh, 21.7 is an outlier. So first of all, find the boundaries for the outliers. Boundaries for the outliers. So basically Q1, uh, Q2, Q3, and Q1 is given 0.1 and Q3 is given 4.85. Then IQR is 4.85 minus 0.1, that is going to be 4.75. And now lower boundary is Q1 minus 1.5 times IQR. So Q1 is 0.1 minus 1 point times IQR, that is 4.75. So this is going to be less than 0. I'm not going to calculate that one. Then upper boundary Q3 plus 1.5 times IQR. So Q3 is 4.85 plus 1.5 times 4.75. So this value has to be 11.975. Now any values this greater than this value is going to be outlier. So the given value is 21.7, so 21.7 is greater than 11.95, so this value is boundary 11.95, 21.7 here, so this is an outlier, means 20.7 is an outlier. Part B, give a reason why you might include this. Why we need to include the outlier. Outlier is the extreme value. So it is unlike B and erroneous value or anomaly. If we see 217.7 something, yeah, it could be a recorded error. So now it is unlikely to be erroneous value. So hence, if it's not a erroneous value, so then it is actual data. So actual data should be in the distribution. Hence, it is likely to be an actual value. Hence, it should be a part of the distribution data. Um, the other one, the part two, exclude this day's reading. So exclude the outlier. So what is the reason for the exclusion? So 20.57 is not a uh, typical value, or 21 point is not not a value of typical rainfall, something like that. What is usually happening, the historical values in the mind, in the brain of the people, how it's look like, the historical pattern in the brain. So the people will match with this historical pattern, historical values, and so then we can count it's not typical, or it's not normal. It is typical. It's not normal. Sorry, it is typical or normal. Part C is the we have to draw the scatter diagram, so you can do the scatter diagram, and rain and sunshine. Then you will see a negative, weak negative correlation. Part D, and part E. Do you think that there is a causal relationship? Yeah, there could be a causal relationship because sunshine not depend on rain, and rain depend not directly not depend on sunshine. Uh, yeah, good. Be a intim, intermediate. That could be causal. So the reason is, yeah, more rainfall mean more clouds. Because of more cloud, less sunshine. So the third variable is the clouds. Let's say area of the clouds. Uh, because of that, there could be a causal relationship, as the days with more rainfall will have a more clouds. which stop sun sunshine. This is very easy section. Now we'll move to linear regression.